We were told 5G would deliver lightning-fast internet. But if you check your phone right now, your cellular data speeds probably max out around a few hundred megabits per second. That's a problem because engineers are designing a world that relies on fully autonomous smart cities, real-time remote surgeries, and high-fidelity holographic video calls. Those overlapping zero-latency systems demand massive amounts of constant data. Our current 5G networks lack the raw capacity to handle them all at once without crashing. This chart shows exactly why we need the next generation. While 5G peaks around 10 gigabits, the target for 6G is 1 terabit per second, 100 times larger, dropping the delay between devices to almost zero. Reaching these speeds requires moving beyond the microwave frequencies used for decades and moving toward the high-frequency terahertz band, where signals begin to behave more like light than traditional radio. To find that missing speed, researchers are abandoning the crowded frequencies we use today and moving way up the electromagnetic spectrum into the terahertz band. This visualization shows a terahertz wave. Because it oscillates rapidly, it packs massive data in a fraction of a second. But there's a trade-off. When this wave strikes a wall, tree, or heavy rain, it instantly scatters. Its range is incredibly short. Because of that short range, the giant cellular towers spaced miles apart in your town right now are completely useless for broadcasting a terahertz signal. Telecommunications companies have to draft a completely new physical blueprint for how to cover the globe in a stable internet connection. Cracking the terahertz range limit effectively sets the technical requirements for every smart city and connected device built in the coming decades. The only physical way to bypass the range limits of terahertz waves is extreme density. If you look at this schematic map of a planned 6G city intersection, you can see how the network relies on hundreds of tiny transmission nodes installed on almost every building, car, and street lamp. To keep all those local devices connected when moving between cities, that dense ground grid has to constantly link up with massive fleets of low-orbit space satellites. Shuffling gigabytes of data between moving cars, fixed street lamps, and speeding satellites requires real-time artificial intelligence just to manage the chaos. This integration of orbital satellites and ground sensors creates a synchronized network that uses AI to predict and route data pathways in real time. Building an integrated space-to-ground pipeline requires massive capital, and one nation is currently outspending the rest of the world to get there first. China has already launched the world's first experimental 6G satellites into orbit to begin testing high-frequency space transmission. Domestically, the government is funneling billions of dollars into advanced research labs and heavily backing telecom giants like Huawei and ZTE to push the hardware limits. The strategy is strictly scheduled. Chinese firms are racing to lock in thousands of global patents and dictate the technical standards for 6G before the year 2030. By establishing the underlying patents and the physical hardware first, China ensures that governments and companies worldwide will eventually pay a toll to use their proprietary system. For the average person, a fully built 6G city means spending every day surrounded by a tightly packed grid of data-emitting antennas, which forces a very realistic biological question. Is it actually safe to walk through a dense, invisible web of terahertz radiation? This cross-section diagram illustrates the physics of non-ionizing radiation. Because terahertz waves operate at such high frequencies, they lack the energy to penetrate deep into human tissue, interacting only at the very surface of the skin. Major international authorities, including the World Health Organization, currently maintain that there is no proven evidence of harm to humans when exposed to this type of radiation at regulated levels. But because 6G multiplies the sheer volume of transmitters across our streets, overall exposure will increase. That density demands strict output regulations and continuous long-term medical studies. 6G sets the technical architecture for the next generation of global connectivity, and the quiet race to secure its patents is already determining which nations will control that infrastructure.